Alright team, it's your boy TheKaneologist. We're going to be doing another Leetcode today. So this one is called Isomorphic Strings. Given two strings S and T, determine if they're isomorphic. Two strings S and T are isomorphic if the characters in the string S can be replaced to get T. Okay. All occurrences of a character must be replaced with another character while preserving the order of the other characters. No two characters may map to the same character. Okay. But a character may map to itself. Paper. P-A-P. So T-I-T-L-E. Okay, so basically what it's saying is, so if you look at egg and add and foo and bar, they're both three letters, right? Foo and bar. But foo has two O's, which means that if you want to replace to get bar, right, you would either have to have two A's instead, because you can only map the same character to that. You can't map two different characters to the same character. It's like egg and add, right? They replace G with D. So the positions and the placements and the letter type is the same if you swap. So D maps to G, right? So I change G in both places to D, and I get that. The same way I do paper and title. I change P in both places to T, and I get paper. I get title. So T-I-T-L-E, P-A-P-E-R, right? So T-I-T-L-E, so the two T's, and P-A-P, right? And then for A, it's I, and then for R, it's E. Okay, did they give us any? S and T consist of any valid ASCII character. Okay, so that's like any of those this is a fantastic free tool, by the way. Add to egg. So I want to find a way to swap these individual characters for these individual characters. So I either have to use a dictionary of some sort. But the thing is with these isomorphic characters are that I need to make sure letters are in the same spot. So for example, D and D, G and G are in the same spot. So if I swap it, so even if this was app, because the letters are the same, I could still swap to get egg. Because this is only three letters, it's easy, right? But I want to be able to check if S and T are both isomorphic. So the first step in determining whether they're both isomorphic is the length. So if the length of S is not the same as the length of T, then by default it's not isomorphic. So return false. That's my first, it's not an assumption, it's kind of a tell here. Because every character needs to be replaced, so that means every character must then be of equal length. So let's return that. I should get one passing test case. Oh. This is the good thing about your code. When the compiler returns a false, see, look, at least one of the cases is true. Right? For bar and foo, return false. Now I have to find a way to create signatures. Like find out where the elements are set. Isomorphic. All occurrences must be replaced. Okay, so G and G, G and D, E and A get swapped. The lengths are not the same. If length is not equal to length of T, false. Oh, T length is equal to S length. Okay, so that already removes this constraint. So I could just return false here. I'm thinking, how do I make sure, how do I check? I have to create a consistent way to do this. If I can do it with 3 letters. There's got to be some sort of trick. Isomorphic words. Python. Check if the strings are isomorphic. Yeah, so it would involve 2 dictionaries. So let's create smap equals this dictionary, tmap equals this dictionary, Now I have to find a way to reference letters. Okay, so I could just reference each letter and then go for I and read 0 to line S. S map the letter. So S map SI, so the letters of SI equal So what I'm going to do is if letter is not in S map, I'm first going to map it. So I did completely get to take a look at their whole solution. I saw something with 2 dictionaries. I might just need to use one and see if it maps to the other. So S maps I is equal to T at I. New word. I'll create an empty string here. So if this mapping is correct, so I basically take the letters of E. If E is not an S map, map it to T at I. And then G, if G is not an S map, then map it to that letter at I. So then I could swap these letters. So now I can build, so now I can go for so basically now I'm going to map it. So using the positions and thing, I should be able to swap. So for I in range thing, so if, so for so new word plus equals, because I'm going to add to this string and then I'm going to reference characters from that dictionary. Then I'm going to return, so that should now add characters to this new word, and then I'm going to return if it's equal to T or not. This is the best way I could understand it. The other solution had like 2 dictionaries and shit. I don't think we need to do that. So new word equals T. No fucking way, that actually worked. My assumption worked. So basically what I was saying was, I go through all the elements from 0 to S for S, that I get the corresponding T if it doesn't already exist. So for example, E, it doesn't exist in the S map, so I get the corresponding A to map it to that, so A. Then G doesn't exist in the S map, so then I use D. And then I go G again, it already exists in the S map, so nothing happens, I don't do anything. So then now I go to 4 and I build it. I build a new word with the mapped letters from egg. So the original letters. So all I go is new word, empty string, and then I add whatever the letter is at that position. So new word S at I. So new word S at I is E, maps to A. New word S at I is G, maps to D. New word S at I is G, maps to D. And then now I check, is this new word add equal to add? Yes. So it'll return true, else it'll return false. So if I put foo, it'll be F maps to B, according to this. Then it'd be bar, so foo and bar, so F maps to B in bar. Then O maps to A in bar, right? And then O's already in the map, so it's not going to map to this R. So if I go to the new word, it's going to be foo, right? So it's going to be F maps to B, O maps to A, O maps to A. So you're going to get ba instead of bar. So that'll be false. So let's try to submit it. So it works according to my assumption. Dude, I see some of these solutions, you have to draw inspiration from the parts that work for you. Like sometimes I just look at some shit and I'll be like, yo, this is too long for me to read. So I'll just look at something I see, okay, a dictionary. So one of my initial assumptions is correct. Let's play with my assumption. Rather than like go and follow someone else's solution, because then you don't get the full value out of it, right? Like you don't get to explore your own thought process and build your muscle for solving problems. So without further ado, let's hit submit. Come on. No. Yeah. Okay, what if I do it backwards now? So basically, I did it one way. Maybe this is why they did 2 dictionaries. They just stack. Let's try new word S. So I'm thinking I just do it in reverse. Because right now I might get false cases. So my output is true. I want to increase the chances of getting a false. So all I have to do is just stack the test case again. So all I do is the exact same thing. I create a T map and then map it backwards onto T. So for example, if S, then I'll copy this whole thing and just do it the opposite way. So I'll build my T map as well. So if T at I is not in T map, T map, T at I. So basically I'm doing the exact same thing I did originally, except I'll do it for the T map and then see if the T new word is equal to the S new word. T map T at I equals S at I. S map S at I equals T at I. So then I do the exact same thing here. So this is new word S equals S map S at I. And then I will copy this because they're the same length. If you look at the constraints, these are the same lengths. So T length is equal to S length. So I could go new word T. T map T at I. So if new word S equals T, and I'll put and new word T equals S. You see, like, all you gotta do is stack the test cases to create more chances for it to be false. So it has to both map this way and this way. We map for S to get egg, we map add back to get T. There might be a case where it doesn't work out. So let's try it. Submit. Come on. Come on. Yes! I'm super Saiyan, bro. I'm Super Saiyan. I'm a fucking Super Saiyan, bro. I'm a fucking Super Saiyan, bro. I'm a fucking Super Saiyan. I'm Goku back when he beat Majin Buu. And he just unlocked Super Saiyan 3. That's me right now. Did you just see that? Did you see that? My assumption was correct. These 34.72% of other people in memory. It beats 5.09% of people. It doesn't matter if it's not the greatest solution, right? But do you see what the logic entails? All I'm doing is stacking the logic that I did with S map onto T map. If S can be swapped to get T, T can also be swapped to get S, and now I have 2 sets of test cases that could run against each other. So I could go, and I create an AND condition here. So I build this, go back, build this, go back, swap all the letters here to get S, swap all the letters here to get T. And if I get both cases where I could map onto each other, then it's a true output, and it ends up working. This would be O of 2 of n, so 2 times n. So it'll be O of n space because it scales with the number of inputs, so the number of string length. So if I had a character of all different strings, like letters in the string, it would be proportionally bigger over time. So it'd be O of n times 2, O of n times, this would be O of 1, because it's just a string, times 2. This would be O of 2 of n time, O of 2 times n. This would be O of n for each element you got to map, then I do it again. Each element you got to map, then I do it again. So O of 4 times n, basically. So O of n, 2 of n times 2 of n, or plus. So that's O of 4 times n. And then this is O of 1, because this is true false. So this reduces to O of n time, O of n space, and yeah, O of n time, O of n space, basically. And that's the solution, and it works, and it passes all the test cases. So like that video, please give it a thumbs up, like, subscribe to the channel, leave your comments below. TheKaneologist is out. I'm Super Saiyan.